Here are the hints for questions 6 and 7 on the 8.3 worksheet. Number 6. An airplane leaves the airport on a course of 150 degrees at 425 miles per hour for 1 hour. Then changes course to 40 degrees at a speed of 450 miles per hour for 2 more hours. How far is the airplane from the airport? Taking a look at the picture, we started with our first north on that left-hand side, so the airport is over here on the left. The plane traveled 425 miles at a bearing of 150 degrees, changed course, so I drew a new north, like so, with a course of 40 degrees. 2 hours at 450, that's where the 900 comes from. So the plane is over here at this time. If we're trying to figure out how far away it is from the airport, we're just going to connect and create a triangle. This problem is very similar to the one we did in our note packet. Now we want to figure out that the length of that opposite side by applying either law of sines or law of cosines. If we know those two sides, the 425 and the 900, we would need to figure out the measure of that included angle. We know the right-hand side is 40, we just need to figure out the left-hand side. Remember, if we have two norths, the angles in between them are called consecutive interior angles, and they add up to 180. Therefore, if we do 180 minus 150, the angle on that left-hand side would be 30. So this angle over here, oops, get that to fit in there, which means the angle total would equal 70 degrees. So I'm just going to arrow to that. That would be a 70-degree angle. This would give us side angle side, and we would use law of cosines then to solve. Here's question 7. From an iron post, proceed 500 meters north, 45 east to the brook. So the iron post, I'm just going to call it I, is over here on that left-hand side. If you don't have everything that I have written down right now, make sure to do that as I read through the problem. We've got a north right out of the gate as we go north 45 degrees east. We go 500 meters to a brook. Then we go due east, so just straight across. I'm going to draw another north here, 300 meters till we get to the old mill. Then we go south 15 degrees east, so I'm just going to write that little S right there for south, 15 degrees east till we get to Trigg Trail. And finally along Trigg Trail back to the iron post. So having everything labeled the way I do is going to be helpful as we try to figure out how to solve the problem. It says, what is the shortest distance from the iron post to the old mill? Well, the iron post is on that bottom left-hand side, and the old mill is across the diagonal. The old mill is over here on the right. So we're looking for this length right here. Now we know the 500 and the 300, and we've consistently been trying to find the angle in between. So if we can figure out the measure of this angle, we'll be able to use SAS, and that allows us law of cosines. Notice when we say north and we go due east to the old mill, I've marked that as 90 degrees. On the opposite side of that, I've got a pretty big angle that would be 180 with the 45-degree angle, since they're in between the two north parallel rays. If we do 180 minus 45, that angle on the left would be 135. And that will be helpful because then that pivot point around where the brook is located is going to be 360 minus 135 minus 90. The leftover angle is also 135, and that's the angle on the inside. Once you know that, I hope this sounds really familiar to you by now. This is going to be side angle side with the 500, the 135, and the 300, and we're trying to find the length of the side opposite that 135. Again, because of SAS, we will apply law of cosines. See if you can set up that formula to solve. Once you finish this problem, there's one more video for help on questions 8 and 9.